Let's do another lesson for Chemistry PACE 1127. It's the 7th PACE out of 12. And we're going to focus on pages 11 through 18, which is about bases and just a quick intro to salts. I am making this video right between Christmas and New Year in the year 2020. So this is a new flannel shirt that my wife got me for Christmas. And it's kind of chilly outside, so it's a nice day to wear flannel. I don't know what the weather's going to be like when you're watching this, but flannel's nice when the weather is cold. And I am hoping that 2020 will get past us and behind us and we can move on and hopefully some good years ahead here, but we shall see. All right, let's first talk about one of the tests using litmus paper to determine if a solution is acidic or basic is you put this little paper in there and an acid will turn blue paper red. So if it turns it red, that's an indication that it's an acid. If it turns it blue, then that means it's a base. So this is just a little diagram I came up with. I always just, with my students, say something like acid turns it red, kind of emphasize that connection D, whereas bases turn it blue. So you kind of stutter on the B, tying together bases and blue. Kind of stupid, but I bet you'll remember it when you're doing your checkup and self-test, and you'll thank me, okay? Even though it sounds stupid. All right, we talked in an earlier video about what makes an acid an acid. And an acid has a hydrogen in it that it's going to donate. Sometimes it's called a proton, but remember that's just because it only has one proton and one electron. So if it gets rid of the electron and becomes an ion, a hydrogen ion basically is a proton. So if it donates a hydrogen to something else, then that other thing is the base. So this OH is the indication of a typical, a normal, a common base, okay? And this is called the hydroxide ion. So OH is kind of like a gang that you can't separate. And the hydroxide ion combined with a hydrogen ion is what's going to become the water. So you can see that easily, right? Hydrogen is positive, the OH is a negative, so the positive and negative, those two bond together and become water. Then the sodium, which by itself, if it's dissolved in water, will separate from the OH, which is negative, so the sodium becomes positive one. Chlorine is negative, and so that sodium, a metal, will bond with the chlorine, which is an anion, a negative ion. Those two things bond together and form sodium chloride, which actually is table salt. Okay, so when you put salt on your eggs in the morning or on your green beans for flavoring, that's sodium chloride. All right, that is a common salt. However, as page 16, if you look at the chart there, you'll see a lot of other salts. Anything that is a combination of a metal, okay, so it's from the first two columns of the periodic table, alkali and alkaline metals. If there's a metal being combined with an anion, that could be a single element or it could be an OH, hydroxide, or there are other anions. When you put a metal and a non-metal, a metal and an anion together, that forms a salt. And a lot of reactions will also form water as being the other product. In a reaction like this, where an acid plus a base become water and a salt, we call that a neutralization. Both of these have been neutralized, and we have neutral salt mixed in with water. Now we're going to talk a lot more about this in the next section, which is titration, and we're going to need more time, and that's where the math gets involved, okay? So definitely we got to do some videos when we talk about titrations. But let me just end this with a reminder that the PACE is going to talk about two other possible definitions or ways that bases can be defined, and you'll have to do some matching sections and definitions and things. I'm also going to, on the PACE Success website page, put a link to some other videos I found on YouTube. by some other creators that explain those definitions. So rather than me recreating that, I'm going to put their links and you can watch their videos if you feel like you don't understand it after reading the PACE and you need a little more grasp of those definitions, okay? But generally speaking, an acid has a hydrogen that it's donating, and the more hydrogens it's able to donate, the stronger the acid. And then a base, you will often look for the OH, okay? So that'll cover most cases for acids and bases, and then there's a few other unique definitions that you'll read about as you study the PACE. And that should take you up to the second checkup. And now I need to go study and make sure I have my head in the gear before we talk about titrations. That is a challenging section, but we'll be here for you and we'll help you get through it, all right?